Hi, good morning. Yeah, so the link for this webinar, I just passed it in the chat. It's over here. And that's a place where you will find the recording once it gets posted. And as always, all of the material is also posted in our main website and in our YouTube channel. And if you want to follow along, you can open the slides and you can maybe see things better than on my screen. So today I would like to talk about a tool called DVC, Data Version Control, and that's actually a tool that is new to me. So this was an exploratory experience, and I think it's a very interesting tool, so I'll share what I've learned about it. So I'm assuming for this webinar that you know what version control is, you know the benefits, and you have some familiarity with Git. And if that is not the case, before you jump into data version control, this is obviously where you should start. And Git is truly an absolutely phenomenal tool, and we teach it regularly. It's just absolutely brilliant. And it was initially developed to put the Linux kernel under version control. And this is really what it shines for. Code, text files, software development. This is really where Git is fantastic. And increasingly, people are also using Git to put into version control their writing. So that can be their thesis, their research paper, a scientific article, a report, because you can version control with Git any text file. So if you use LaTeX or Markdown or R Markdown or Quarto or whatever, then you can version control all of that. But this is really for text files. And when you deal with data, large data set, or now in this exploding field of machine learning, when you deal with very large models and very large data, there's just a lot of established workflow that's just lacking. Like the workflow that was developed a long time ago now, thanks to Git, to have good practices when working with code and text, is struggling to catch up when it comes to big files. And so a number of projects have been developed to put data under version control, and they have different functioning. I've put very purposefully here only open source tools. There are some commercial tools as well, but really open source tools totally shine, and there's no reason to look elsewhere. And things like DataLad, for instance, are this very great tool. DataLad builds on Git Annex or LakeFS, and they all have a different functioning. And so depending on your use case, it's good to explore the different options to decide what might suit your purpose best. But really, the tool I'm going to talk about today, DVC, it does that, of course. It allows to put your data into version control, so you can track versions over time. But it's really built with this idea of scientific experimentation in mind. They frame it in the context of machine learning. If you look at the website, it looks like it's really a machine learning tool. And it's true that in the context of machine learning, this kind of tool is particularly critical. But as soon as you have a scientific experimentation, so some code running on, or some model, or some simulation, or some whatever running on some data, then that's a tool that's particularly interesting because it adds a lot of functionality over all of those other tools that I've mentioned previously. And so this is what I mean by the kind of new scenario that machine learning and a lot of other data science fields have brought. You have a lot of moving parts. It's not just your data that is evolving over time, but in the case of machine learning, but again, you can think of that in any scientific context. You also have some code in machine learning, you have those big models, and then you have additional moving parts, such as hyperparameters, for instance, and all of these things combined. And here I'm only putting 3 data version, 3 hyperparameter version, and 3 model version. You imagine that it's just so that I have a little scheme here that's readable on the slide, but in real life, we're talking way more iteration, particularly in machine learning when it comes to hyperparameter. Like people run things across fields of hyperparameters to see where the best performance is. And so here, with just like a couple of moving parts, I have already 27 different outputs. And if you keep switching everything here and there, then if you find that a certain output really has the best performance, that's the one you want to reproduce. Or like, it's just very hard to keep track of, okay, which version of the data was this one used, and which version of the model, and with which parameter, and producing what metric. And when you collaborate with people, if some people are involved in part of the data processing, and some people are involved with some tuning of some parameters, and other people are involved with other things, you have this like insane system, and you can see that just keeping track of the data isn't sufficient. So DVC really tries to fill in that goal and develop some good practices, some good workflows with the idea of reproducibility, collaborations, establishing some pipelines so that things can be tracked over time, and all those moving parts can be handled in some proper way. So the principles DVC are built upon, when it comes to data, it's very similar to what you will find in, for instance, Data Lab, which is built on Git Annex. The large files are kept outside of Git because Git is really designed and excels at tracking text files. But each of these data versioning system have some kind of way to have some metadata tracked by Git. And so in the case of DVC, whatever directory full of files or very large file or combination of files you want to track as a unit, once you put it under DVC tracking, a little .dvc file, which is a very simple little text file, gets created. And this is that metadata that you put under Git version control. And meanwhile, DVC takes care of the rest, which allows for, as I said, collaboration and reproducibility, and also the rerunning of pipelines whenever anything in that pipeline moves. So it also plays a role very similar to a Makefile. You know, the Makefile is a very, Make is a very old school and still incredibly powerful tool of where you create a Makefile stating some dependencies, some programs, some outputs, etc. Whenever anything moves in that system, running the Makefile allows to rerun just what needs to be updated in that system. And DVC, among other things, does exactly that in those big data science pipelines. So little practical things to install it. It is written in Python, so you can install it very much as you would install any Python package from the Python repository. So you can install it with pip or with conda. And you can run it in Python as a Python module, actually, if you install it with pip or conda. If you don't intend to use it as a Python module, and if you don't want to have to create a virtual environment and activate your virtual environment whenever you want to have access to that tool, you can also install it with pipex, which is what I did actually, because I think it's the kind of utility, kind of a command line tool that Pipex allows to handle very nicely. Pipex will create an isolated environment that will isolate the tool from the rest of your system so that there's no conflict with your globally installed packages, but you don't have to activate any specific virtual environment anywhere to have access to the tool. It's accessible system-wide in its isolated environment. So Pipex is great for tools like this. And I see that Alex posted in the chat, indeed, everything I am talking about is for Linux, because I am on Linux. Indeed, on Windows and on macOS, things will be a little bit different. It is cross-platform, so you can use it anywhere, but you should go to the documentation, which is very thorough, to see how to install it on your platform. Yeah, so everything I'm going to say in this talk is going to be Linux-based. Thanks, Alex, for actually reminding me that there are other OSs out there. Now, because we don't want to put those very large files into Git, we don't want to upload them into things like GitHub. GitHub has a strong limit on how much you can upload anyway. You probably will want to use some remote storage to run with that. And so that can be Google Drive, that can be the Amazon cloud service, that can be some server that you access through SSH. There are very many options that are covered. But you can install the dependency that corresponds to the remote storage that you are planning to use when you install. So instead of running, for instance, pip install DVC, you would run pip install DVC and then square bracket J drive if you plan on using the Google Drive dependency. And then how do you run it? Well, if you want to have it available everywhere, you can just run some DVC command on the terminal, very much as you would run a Git command. If you use VS Code, VS Code is this incredibly amazing and very popular modern text editor. I don't use it myself because I use Emacs, but it is really a brilliant text editor, I have to admit. It's a text editor that has, like all cool new modern tools have extensions for this text editor. And so DVC is no exception. And there is an extension that allows you to run things directly from VS Code. I forgot to add in this list actually, but they even have their own GUI interface. It's called, I don't know, DVC something. I should add it to the slide. It's a very tool-specific GUI, so I think it might make less sense than those much more general approach, but they have their own GUI if you want to use that as well. And then something that's quite cool is that you can even, as I mentioned earlier, use it directly from Python, since it's a tool that was written in Python, and in that case, you can just import it as a library. So for this webinar, I'm going to use it from the command line on Linux. And to be clear, I did modify things a lot, and I went through a lot of material, but the data that I am using here initially came from real Python, a workshop they built on DVC, and then the Data Lab handbook, since Data Lab is somewhat similar to DVC in some respects. They compared both tools, so they simplified the real Python data, and I got the data from there. So I'm using a lot of their code and data here, and of course I'm using a lot of the DVC documentation. So I didn't come up with the Python scripts, for instance. A lot of the stuff I took elsewhere. I wanted to be clear on that. So the data that I downloaded from those various workshops, I installed on my machine on a directory that I called DVC. And if we look at what is in this directory, you can see the structure here. And at the bottom here, you might not be familiar at all with this, and so it might be more disconcerting than helpful. And if that's the case, just ignore it. But in case that helps you, this is a second terminal that I am running down here, and Ranger is running in it. So Ranger is a command line tool that allows to see directories in your file system and the content of directories in a GUI-like nice interface, while in fact it runs in the command line, which makes it super fast. It's really cool. And so as I run things, I will not run anything in Ranger, but as I do things in the terminal, you can keep an eye on what's going on in here to, if that helps you to see in action the kind of changes that are happening. And if my font is too small or something is not easy to see, by all means, type in the chat, jump in. I can reconfigure things to make it good for everyone. So this is the project. There is a real Python license that I want to keep because, again, I'm stealing the project. And then there is a data directory with two subdirectories, a raw one and a prepared one. The prepared one is empty. The raw one has two directories, train and val. So that's for the training data and the validation data. And those have two sets, and the sets contain a bunch of images. And then there's a number of directories that are empty, such as metrics and model, a requirements text that I created for the packages that I will be needing, and then some scripts that we will use later on. So as you can see, if I run ls-al, there is no hidden files here. So everything that you see is everything that there is to see. This is not a directory that is under any form of version controlling at this point. It's just a collection of directories organized in a structure that is coherent and that makes sense in the context of data science. For now, that's really all there is. And so that's what you can see here. So this is my DVC at the bottom in Ranger. So in DVC, I have data. In the row, you can see that there's train and eval. And then there is two sets in each of them, and each is made up of a bunch of images. So that's the structure of the project we will be using. So you can use DVC without using Git, but that would be quite silly because you wouldn't be able to do any versioning. So you could still do some of the functionality, but it really wouldn't make sense. So DVC should be used in combination with Git, and they have a bunch of commands that sound similar, and they're closely connected and interdependent when you work with DVC, but they play very different roles, and their structure, the way they work together is a bit different different from DataLad, if you're familiar with DataLad, for instance. So they're a bit more kept separate than in DataLad. So the first thing that we need to do is to initialize a Git repository to start a classic version controlling of this project with Git. So if I run git init, I've initialized this repository. And so the command tree and ls don't show any change, but if you look at the bottom in Ranger, you can see that a .git directory has appeared. And now if I run ls-a, so the a flag for all to show hidden files and hidden directories, you can see that I have a Git directory. So now I am in a Git repository. So if I run git status, you can see that I am on branch main. That's the default branch created by Git. And of course, I have a bunch of untracked files and directories because I haven't added anything. I haven't put anything under version control. I have just initialized the repository. Before putting anything in Git, because we have things like data, for instance, here, and I've already mentioned we don't want to put data under version control, let's also initialize the DVC project. So it's very similar to start. It's DVC init. You'll see that's a common theme. A lot of the commands are very similar to the Git ones. When you run that the first time, in addition to this, you will see a little message that they're telling you that they're collecting anonymized data analytics, and you can opt out of it if you wish. I have, that's a personal thing, but so that's why if you're running this at the same time as me, things would look a little bit different. And so now I have new files that have been created. If you look at the little ranger window at the bottom, there is now a .dvc directory and also a .dvc ignore file. And I can show them here as well. Okay, so now if I run git status again, and just to save me some typing, I have a bunch of shorts and aliases, and so GU is my alias for git status. So I'll just type that for the reminder of the webinar whenever I want to run git status, because that's something we run so often in Git. So the files that were untracked are still untracked, of course, but now those new files that were created by the command DVC init were automatically staged by DVC. And that's cool and that's convenient. By default, this is the only time when this will happen, at the initialization of DVC, but you can configure it either for this particular project or globally, or even system-wide DVC, so that for each new DVC system file, the same thing will happen. And I don't see any reason not to do that. So I have actually set that option. So I won't have to stage those DVC system files automatically. Now, that's up to you, and as you play with the tool, you'll develop the workflow that works, and you'll configure the tool the way you want. But so because those system files have already been staged, I can directly write a commit. So that's going to be my first commit, and I'm going to put all those system files under version control. So now those system files are under version control. And if we go, I'm on the bottom window here into Ranger, you can see what those system files look like. In the .dvc, there is a config file that is empty, but this is where you could add the configuration of DVC for this particular project. A .gitignore that was automatically created that contains a number of things that shouldn't be put under version control with Git. And not much else. So for now, there's not much going on. This is just the starting point. So because we will run some Python scripts, I will create a virtual environment and activate it. And I realized just before the workshop that a couple of oh, yeah, right. Okay, yeah. Yeah, I reran the things just before before the webinar, and I realized that something was missing in my slides, and now I realize what it is. It's that I'm not activating the packages based on my requirement file. So I'm going to run this. I'm going to create a new virtual environment that I'm calling venv. I'm going to immediately create a .gitignore file with this virtual environment in it, because I certainly don't want to put the virtual environment in version control. And there's a lot of gitignore in this workflow. So if you get confused, you may not have been aware of it, but with Git, you can put gitignore wherever you want. So usually, often we have one .gitignore at the root of the project, and this is where we put everything. So I don't have one yet, and by running this, I'm going to create one, and I'm going to add venv in it. But I've already mentioned some gitignore because DVC creates a lot of .gitignores in specific directories. That's the way it functions. And so you'll see that a lot of .gitignores will get created automatically by DVC in various places. And that's something that you can totally do with Git. You can have .gitignores anywhere in your directory. And of course, the blobbing patterns and all that will match the starting point of the location of the .gitignore. So only a .gitignore at the root of the repository could take action over your entire project. So let's run this. And then, of course, I am activating my Python environment. Now, I need to run to install the requirements, and so install from requirement. I don't remember exactly what the cleanest command is. So install packages requirement. So pip install -r. Okay, so let's do that. That's what I will add to those slides right after this. So I am installing into this virtual environment, venv, that I'm now in, the requirements. How have I? Oh, yeah, I have a little typo here. There we go. So for this little example, we will need NumPy, pandas, scikit-image, scikit-learn, and a couple of other tools. So I'm installing them so that I can run the little script. Okay. Yeah, and I should install pip, update pip, but that's okay for now. Now, if I look at what's going on, I still have the same untracked files, and in addition, I have this new .gitignore that I created with the virtual environment. So let's do a little bit of cleanup. I could stage or add to the staging area the gitignore file, the license file, the requirements file, and create a commit that, with the message add general files. And then I'm going to stage the Python scripts that are in the src for source directory and create a different commit for that with add scripts. So I'm going to clean things up, except for the data. So now, if I run git status, I've created those two commits, so I've taken care of all those loose files, but I still have this data directory, and this is where I need to start using DVC. So if I run DVC status, which is kind of the equivalent of git status, it tells me that there's no pipeline and no data tracked on this project. It's the same as with Git. After you run git init, there's nothing that's being tracked until you add things. So we will add things. And you can add data however you want. Like all of the heavy files, I mean, they're not very heavy, but the files that I wouldn't want to put under Git version control are under data, raw, train, and eval. And so I could put each individual image under DVC tracking by itself. And then to have DVC notice that something has changed, I would have to modify that particular image. If you have some very large file, it would make sense to track individual files. Here, it's a collection of images. It doesn't make much sense. I could track all of data as one unit and create a single .dvc file for the whole data directory. But then if anything changes anywhere in that data, I will have to rerun things. So you have to find the level that makes sense. And in this case, what makes sense, I think, is to keep train and eval as two different units, so create two .dvc files. You could decide that tracking per set of images makes more sense. It depends on the workflow. But I will do it for data row train and data row val. So I will run two DVC add comments, and that does a number of things. Where is the data stored in DVC? If we go back to the .dvc directory, initially there was no cache, but now we have a cache directory, and this is where the files are, the images are, with an MD5 hash, and the MD5 hash corresponds to the new .dvc files that got created. Now, in the data row directory, I have, where I had the train and val directories, I have a train.dvc file and a val.dvc files, and they have an MD5 hash that corresponds to the cache. So if I run git status now, I have all these new files, and they are already staged here because I have set this particular configuration to have this done automatically. By default, they wouldn't be. I would have to stage them. And so we have this these new train DVC and val DVC, and there is also this new .gitignore that got created, and that is telling Git to ignore train and val because those are where the original data is, and we don't want Git to track the data. We just want Git to track the metadata that is train.dvc and val.dvc. And if I look at for instance, one of those DVC file, for instance, train.dvc. It's a bit hard to see, sorry. Maybe if I highlight it, well, no, it doesn't help. So I can show it maybe here. You can see it here. It has, as under the outs category, which corresponds to the output of that DVC metadata, the MD5 hash that corresponds to the cached data. So, oops. There is something that you might be wondering, and it's about data duplication. because we have the data already in data row. And now, in addition, I have the same data in the cache, right? So how does that all work? So there are a number of options. By default, the first things that DVC tries is to create ref links. And ref links is the ideal thing. It makes sense to have this by default. It's great, but the problem is that it is only available on very few file systems. For instance, on Linux, the very new BT RFS file system allows to have those cow, like copy on write ref links. So the way a ref link works is that no copy is made when you create the ref link, but they point to the same blocks in memory. And so you have no duplication, so things, it doesn't take extra space, it's done instantly. But things are editable and editable safely, because as soon as you edit one of the version, then a copy is made. This is what the copy on write thing is. So copies will get created, but only where necessary. So this is great, but I don't have access to it. Most of you won't have access to it. So when DVC cannot do ref links, the default is to do a copy. So what I did here, because I haven't changed the default, is actually copy the data to the cache. So copies are great because, of course, you can edit things. I can edit the files that are checked out into my working directory. But this duplication is slow, it takes some extra space. So if you work with very large data, that's probably not something that you want to do. The link between cache and working directory shouldn't be a copy for like extremely big things. But you can totally customize it to have the default then be either a hard link or symlink. And DataLad, for instance, by default has symlink. So if you want to match the behavior of DataLad, you can put symlink. So symlinks wouldn't do any, or hard links for that matter, they wouldn't do any duplication. So it's fast, doesn't take extra space. Now, the problem is that if you create a hard link or a symlink and you edit your files, your data files, it would break the functioning of DVC. And so DVC by default make things read-only. You won't be able to edit. You can if you force it. There are commands to force it, but then it will break certain functionality for the tracking of the data. So that's not something that you should do. So unless you're lucky and you have access to ref links, the trade-off is, do I want something that's editable? If you don't play with very large data and you want something that's extremely, and you need to play with the data, then that's the way to go. If you play with very large data and the copies would be very, wouldn't be good in your system, then go with a hard link or a symlink. Change the default, go with the DataLad behavior, but then you'll have read-only things. So yeah, so in my situation, I do have data duplication. So DVC tries to optimize things, but yeah, it is local. Right, yeah. I'll talk about that when I start talking about remotes. Yeah, because for now, I haven't set up any remote yet, and that's a fantastic question. For now, it's only a duplication between the cache. Think of the cache in terms of Git version control as what's in your .git directory with Git. And think of the files that you can access and see and all that as the equivalent of your working directory with Git. With Git, you have the same system. Whenever you create a commit, a snapshot of your project is taken, and a very compressed file is stored in the .git hidden directory. And whenever you check out any commit, whatever corresponding data gets uncompressed, and this is what you have in your working directory, and this is what you can navigate. So in Git, you have data duplication, but because Git works with text files, this duplication is of absolutely zero concern, so that's why you never think of it as a form of duplication, because it's marginal, whatever. But this is exactly the same. What you have in the cache is your like the history of all of your data versions, if you want, and the one and what you can see when you go to, so in the .dvc, if I go to the cache, like this is my like my snapshot, if you want. And for now I have just the one, but I could add many more. But then if I go to data and I look at the actual data, this is the uncompressed, checked out version of the data that's in my working directory. So this is kind of like the within a repo duplication. Then to collaborate with people, we'll have to create a remote and all that. And yes, I'm going a little too slow over the workshop, so the webinar, so I should try to go a little bit faster. But hopefully that clarifies things. Yeah, that's an excellent question. So I have these new files, so let's create a commit with those. So I'm calling it, to follow what I did here, commit called initial version of data. So if I run, this, now my Git status tell me on branch main, nothing to commit, working tree clean, because I've created a commit with those automatically staged files. Now, if I run DVC status, initially, DVC was telling me no pipeline or data tracked, like there was nothing under DVC tracking. Now, there is something. There are those two DVC file, one for each of those two subdirectory, but they're up to date. So it's all good. Now, let's make a change to some of the data to see what happens. So let's say that I want to delete all of the files in this directory that start with this pattern. So that's going to delete some, but not all of the pictures in one of the tracked directory. Okay, so now if I rerun DVC status, you can see that, okay, there is a modification in the val.dvc. So because since that data is tracked, DVC is aware of it. But be careful that if you run git status, git doesn't see that, because remember that git is not tracking the data. DVC is tracking the data, but then what we want to put under version control is the metadata. So if we want to update the DVC cache with the changes, I would have to re-add whatever was changed. So it was DVC add data row. It's in the val directory that I made some changes. So now this is sending new information to the cache, right? And if I rerun DVC status, now DVC is telling me that everything is up to date. But now if I run git status, now Git sees changes because the val.dvc has changed. Its little hash that links it to the cache has changed. So this is how DVC and Git play in parallel. So I can create a new commit to have everything clicked, right? Okay. And again, because I didn't have to stage the .dvc file because I have this auto staging on. And yes, of course, I can totally restore the files. That's absolutely the point of putting things under version control. And so one way to do that, for instance, would be to check out that commit that corresponds to the point where I hadn't deleted those pictures. And so let's visualize the missing pictures, actually. So let's go to val. Yeah, it is in that directory that I deleted pictures. So all of the pictures that start with this like EL, SVR, etc., they're gone, right? So the way to restore those images would be to do a git checkout to the commit where, like before I deleted them, and then a DVC checkout to have DVC catch up to the state of the .dvc file. And whenever you run git clone, git checkout, git anything that's gonna make changes to any of the DVC file, then you'll have to run the corresponding DVC command to make sure the data catches up. So it's a little tedious, and mostly it would be easy to forget to do it. And so there's a command that is called DVC install that we will use that creates some git hooks that will do all of that for us automatically. So what this does is that it inside the git directory, there's a hook subdirectory. This is part of git that has nothing to do with DVC. And there are some hooks that are there by default, but we have installed 3 new hooks by running div install. There's a pre-commit hook, a post something hook. So anyway, a post checkout hook. So we have created 3 of those little hooks by running this. And so now, because I have done this, if I run, for instance, git checkout to some commit, in the background, automatically, DVC checkout will run so that the state of the data will follow the state of the .dvc file. So what do I want to check out? Well, I can go back to my Git history to see where I should go back to, right? So this is like classic Git. So the initial version of the data was here. So going back to this commit sounds like a good idea. So let's run git checkout with this commit. And so I am in a detached head situation. As you can see, the DVC checkout happened automatically, and you may or may not have noticed, but all of those files have really popped up. So I have checked out from the cache into my working directory the previous state of the data. So it's all in there. So yeah, this is how you can follow the tracking of your data in a way very similar to Git. Now, because we are in a detached head and we don't want to create commits from a detached head, let's create a branch. Like this is classic Git workflow. This creates a new branch called alternative and automatically switches to it. This is like when you use DVC, you would use Git exactly the same way you normally do. That shouldn't change your Git workflow. So now I am on this branch alternative, and I have restored all of the data the way it initially was. Main is as those deleted things ahead, but let's ignore it because I want all of the data to run the little Python scripts. So we'll stay on alternative now. Okay, so there was a question that was excellent about collaboration. When you collaborate with Git, usually you have a Git remote created that can be on a server, on a remote machine, something you access through SSH, even something that's connected in interconnected computers, or it can be on the internet, such as GitHub, GitLab, etc. So if you were to collaborate on this project with someone, for the Git part, you would do exactly what you're used to. So for instance, you could create a remote on GitHub, associate the Git repo with GitHub, push and all that, and your collaborators would have access to all of the Git files through GitHub the way they normally do, and of course the .dvc files that allow to track the actual data are part of that. So your collaborators would also have that. Now the data should go on something that can handle large data, so some Google Drive, Azure, whatever, or some server, right? So here, and DVC has easy tools to configure any number of those cloud storage and SSH and all that. Here, to keep things simple, I will create a remote on my own machine, just to show you how remotes work. So I will create a directory outside, of course, of the project. It's a remote, so it has to be independent from the project. So remember that in the Unix shell, ... means go to the parent directory. So I'm going to, like if you look at Ranger, I am in the root of my project. So I am in DVC here. I'm going to go up one bit. So I'm going to go in my TMP directory and create a new directory that I'm calling remote. And then I'm going to add this as the default remote for DVC. You can have as many remotes as you want with DVC. The -d flag will signal to DVC that this is the default remote, so that when I push and pull, if I don't specify which remote to use, this is the one that's going to be used. So DVC remote add, again, the syntax is very similar to Git, -d. This is going to be the name of my remote. I'm calling it local remote, and then the location. So of course, instead of this, if you were using a cloud service, you would have some URL that corresponds to wherever this thing is going, or some SSH thing to wherever things would go remotely. Okay, so I got setting local remote as a default remote. And so remember that little config file in .dvc? It had nothing initially. Well, now it has been populated with a little something. We have a first configuration, which is the content of, the information about our remote, its name and its address. Okay, so where are we at in terms of Git? So we have this new little config file with the location of the remote. I want to put that under version control, right? So this wasn't auto-staged because it's not a new file that was created, it's a modified file. So I'm adding it. Again, this is a little short for git add, and then, well, I can copy rather than using my shorts. I'm creating a little commit. And so now everything is clean. Okay, I have configured my remote and put it under version control. Now, the remote, if we go in here, is empty, right? I have told DVC that I want to use this directory that I created as a remote, but I haven't pushed anything to it. So right now it's still the empty directory. So you won't be surprised to hear that the way to push the data to a remote is DVC push. It's very, again, very similar to Git. So DVC push will push the entire content of the cache to the remote. But maybe that's not what you want. Maybe you wanted to push only the content pertinent to one of the DVC files, for instance. Then you would add this. You can also push to a different remote. So there's many ways you might want to push DVC push. Also, as with Git, this pushes all of the versions of all of the .tvc files, but on the current branch I'm on. It works just like Git. So if you wanted to have all of the versions for all of the branches, you would have to add a flag that says so. So here, I haven't pushed the changes on the main branch, for instance, but only on the alternative branch, which is the branch I'm on. So this is to push, and then, so to go back to the question about duplication and all that, there would be yet another copy here, of course, made to that cloud service, for instance, if I were collaborating with someone, and then my collaborator could download the data locally. But you don't have to do that when the data is very big. DVC is capable of having that little hash in the .dvc files connect to a remote path. So instead of having the data in your .dvc cache, the data can be external. So that saves all of the duplication problems. And if you work with very big data, that's the way to go. So because I started with data that I had locally, I cannot show that. But your collaborator here, for instance, could download the project from, say, GitHub, clone the project from GitHub, and not download the data from, say, Google Drive, but keep it there and have it tracked remotely. So depending on the size of your data and the type of storage that you're using, there are very many situations, and some have constraints, some don't. One thing to mention, if you use some storage allow you to do some cloud versioning. And so if you do some cloud versioning, the workflow will be a little bit different, but it's all well documented. And so there's a lot of flexibility in there. So I'm not sure that answered the question very well, but hopefully that clarifies things a little bit more. So to get the data, if you want to download it, you can either run DVC pool, and that will download the data into the cache and automatically check out the version of the current commit. Or you could just do DVC fetch, which would only download the data to the cache, and then you would have to explicitly run DVC checkout to have it to have the data corresponding to the checked .dvc checked out in the working directory. So very, very similar in all of these things to how Git functions. Like there's total parallel between the two tools. So it is noon, so we're out of time, and people were just interested in data tracking. I guess you can escape, but people who have time and who are interested in getting a little glimpse of how DVC can be fantastic for data science and machine learning to track experiments in the sense of having some data and a bunch of hyperparameters or whatever, go through some whatever model, like a whole workflow, a whole pipeline of code that you run when you try to find the best parameters, for instance, or the best version of the data or the best model. Stick around, and I apologize for the delay. people who have to run, this is being recorded and will be uploaded to YouTube. So if you can't stay but would like to see the end, you can watch it later. And I apologize for moving so slow through this. I don't have too much to cover though, so hopefully I don't keep you too long. So this was how to track the data, and there's a lot more that can be done. You can create data registries, and DVC is a very fancy tool. But let's see a very basic tracking experiment workflow. So to create a DVC pipeline, you create a number of stages, so a number of steps that the data goes through. And the command for this is called DVC stage add. And that will, each time you run it, that creates a new entry into a dvc.yaml file. So that's a file that will be in the root of your directory. So you can see that I don't have any at this point. So that's a file that will be created. And each entry contains the command that will be executed, the dependencies, and the outputs. So this is the part that is very analogous to the utility make. So in the example that we have here, we will run a little SGD classifier to try to classify this very minimalistic data. And the pipeline contains 3 steps. First, we need to prepare the data. In the data directory, we have the raw data. This is where our data lives. But we also have a prepared directory that is empty. So we'll run a Python script that will prepare the data and populate this directory. Then we'll train the model, that's minimal training, and evaluate how it does. And the goal here is not to do good training, like everything is minimalistic, it's just to show the workflow. So it's a very, very small example. So remember that for each stage, we want to run a DVC stage add command. So first stage, prepare the data. So I'm running DVC stage add, and then I need to give a name for that first stage. So I'm calling it prepare. And then I want to set the dependencies. So the dependencies, there are 2. It's the script that I will be running, so Python script, and the data that the script will be running on. It's going to run on data row. And then, excuse me, the outputs will be 2 files, train.csv and test.csv, that will be created in this prepared directory. And all of these will run the like the Python prepare py that is in the I have the little scripts here that again I didn't write, I stole from real Python. So let's do this. So the little backward slash, don't let this spook you. It's just because it would be a very long line to put everything in one line. So this is a single command. This is just an end, like a carriage return or like a line break that I'm putting so that the code fits nicer in the little box. But this is one single command if you want. That is running DVC stage add on this Python script with all of those flags, the prepare, the dependencies, and the output. And so you can see that the prepare, that's the name of this step, was added in DVC. I don't know how to pronounce it. So I can look at this DVC YAML file. And so it's hard to see, but it's in the YAML format. I should learn how to pronounce this. So we have stages. The first entry is prepare. That's the one we just created. And then we have the command. That's Python, the dependencies, so the data and the prepare script, and the outputs. Then second step is the training. So very, very similar. So now I have a second entry. I've prepared and trained in my DVC YAML file. And the third one is the evaluation of how this fantastic training went. So now I have a third entry. Okay. So of course, I want to put this under version control, right? Because I have a bunch of stuff that have happened here. First, I have the dvc.yaml file. And again, they're staged because of my auto-staging thing. Then under model, I have a new .gitignore that got automatically created, and it's got this job lib that will be created, and that shouldn't be version controlled. So DVC takes care of all of this, and similarly in the data prepared that was empty. Now I have the .gitignore that tells Git not to track the train.csv and the test.csv that will be created when we actually run the pipeline, because you don't want to track under Git version control the outputs of code. You track the code, not the output, and that's the output of running the Python script. So that's the kind of stuff that you always want to put in your gitignore. So I'm going to create a commit with this pipeline definition. And there we go. So now I have a commit with this pipeline. So cool little things. You can visualize a DAG. So, D something cyclic graph. Like I forgot what DAG stands for, but like you can see a nice little visual of what your pipeline looks like. So we have the train data and the validation data that will both go through the same pipeline of prepare, train, and evaluate. But what's more interesting is the command DVC repro. DVC repro will run the pipeline, because so far we haven't done the training and all that. So DVC repro runs the pipeline. It's called repro for reproduce, because this is where the make functionality kicks in. Whenever we will change the training stick is what is taking time here. Whenever we will change anything in the system, change the data, change one of the scripts, change any of the dependencies of the pipeline, running DVC repro will rerun not the whole pipeline, but only the bits that are required to reproduce the pipeline in a way very similar to what Makefile would do. So I have run the prepare, the train, the evaluate. So, no. Now, what do I have? I have this new dvc.lock file that got created automatically by DVC to make sure that you create a commit each time you run a pipeline. You can disable this if you want, but it's a very important feature because you don't want to run the whole idea of putting your workflow under version control is that each time you run a new experiment, like running the pipeline is an experiment, you want to put that under version control. So the lock will prevent you to run another experiment until you have committed it. And we have a new untracked file in the metrics, which is the output of our experiment. It's the output of the evaluation of the whole experiment. The metric is 0.76. So let's, yeah, exactly. Yeah, it runs the whole pipeline. Well, I had never run the pipeline. So the first time it runs the entire pipeline, right? Because it's like a make file. If you have a number of outputs in your Makefile and the outputs aren't created the first time, the whole Makefile runs. That's what happens. From here on, if I rerun DVC repro, it tells me didn't change, nothing runs again. This is like running a Makefile when you haven't changed any of the dependencies. If I change any of the Python script or any of the data, and then I rerun DVC repro, it will only rerun the parts that are necessary to recreate the full pipeline. So for instance, if I were to change the data on one of the data sets, it wouldn't rerun the Python scripts on the other data set. Like if I change something in the, because you have, if you look at the data, you have two different sets. So if I modified only one of them, things would only rerun on that one. So it's a way to rerun the pipeline rerunning only whatever is necessary to update it. Yeah, exactly. This is exactly what that tool is built for. They built it with, so you can use it for any data science workflow, but they really come from the perspective of AI, and they really do it with the perspective of hyperparameter optimizations. So if you change your hyperparameters, here we don't have hyperparameters that are in a distinct files. They're part of the Python scripts. So it's not really ideal if you just want to play with the hyperparameters. But you could totally imagine, if we go back to the beginning of my presentation, here, you could totally imagine a scenario where your hyperparameters would be kept in distinct files and sourced in the model run, for instance, or have a Python script that would source the model, source the data, source the hyperparameter, and run everything. And then you could iterate over a bazillion of hyperparameters, and if you create a commit each time you are running an experiment, and those commits are very lightweight because those commits involve your performance number, like your little metrics that weighs nothing, and it will have the DVC, the YAML file. So you'll have very little data to put in Git, and you can then revisit any of those commits to see which one performed better, and you can reproduce exactly the workflow for that particular instance that worked particularly well, and you know exactly which data set was used, which model, which dependency, which hyperparameter. So that's really exactly the kind of use case where this tool would be great. Yeah, did I answer your question, Manuel? Or not really? Cool. Yeah, and so this is really a tool that's fantastic for exactly that. Yeah. So yeah, you can use it to just track your data. But if you just want to track your data, the Lake FS or DataLad or other tools would be just as well. I don't think this one is inferior, but it doesn't add any revolutionary advantage, maybe. But if you want, to optimize hyperparameters and you have a lot of moving parts in your system and you want to keep track of all those things, then here this adds so much more functionality, and this is so really great. So as I said, if you, I should stop here because we're running out of time, but here the data and the pipelines are up to date. But if I modify the data, for instance, I add new samples to one of the data sets, so I add new pictures, or I tweak one of the Python script, or suddenly I add some new whatever, like DVC status is gonna, if I change at anything that has to do with this pipeline, DVC status is gonna tell me about it, and I can then rerun things and track things and all that. So yeah, I think it's quite powerful. It's maybe a little bit of complex at first because the documentation covers so much, it's a bit overwhelming. I actually found the DataLad documentation very helpful because DataLad is very clear, very clean, very neat, and DataLad explains the functioning of DVC much better than the DVC documentation, I find. But DVC has all those really cool features. And then you can go further. And so maybe I should give some course or further webinar on this because that can go so much beyond this. This was really just a simple introduction because those metrics that you are collecting, you can visualize them as plots. You can, in the command line, directly output some plots to visualize the performance of all of those hyperparameters that you are tracking. If you want to do some continuous machine learning, there is a continuous integration sister project, CML. There is a Python library called DVC Live that allows you to log all of your experiments. So you can log your experiments into a CSV file or whatever, you can plot them. Like there's a lot of other tools that built on that are particularly useful for machine learning. So yeah. And yeah, I'm gonna stop here. Sorry for running out of time. I might very well give a follow-up webinar or maybe offer a course on it or something because yeah, that's a lot of potential. If you have any question, Alex, I know that you've taught DataLad, so maybe you have questions. So DataLad in their handbook has a section where they compare both tools because there's a lot of people who wonder what's the difference between DataLad and DVC, and so they have this nice section in their handbook that explains the differences, and that section really helped me understand the functioning of DVC more than the DVC documentation. And basically, you can reproduce a fair bit of that functionality in DataLad, but it's like you won't be able to log your metrics and create log plots and to show the DAG and to run a DVC repro as if it were a Makefile very easily. So you could implement all that in DataLad, but if your objective is to do this kind of workflow tracking, I think DVC is just an easier tool. Now, if your goal is only to track very large data sets on remotes, maybe other tools might be better for your usage. So it really depends what the your usage is. Like a LakeFS is very good, not for this kind of science pipeline, but if you have like some very, very large data sets and you have the data coming from a bunch of sources and be pooled in some like big global database that pulls data from various places so that then you can extract bits of data from the database. Like for big database type things, LakeFS would be superior. But for yeah, for this kind of workflow, this is quite unique. So again, you would not put the data on GitHub, but all of everything that is under version control with Git, of course, you could push it to GitHub or GitLab or anything. So yeah, absolutely. But you can't push large objects to GitHub. If you try, GitHub will tell you to use Git LFS. Git LFS is the default way for GitHub to handle very large files. So you will need to have a remote that is either a server or a Google Drive or Azure or like some cloud service for the data. And yes, the Git part goes to wherever you put your Git part, such as GitHub. Yeah, absolutely. But you'll have to have a different remote for the data. Yeah.
I have a question. If you have multiple remotes for the same DVC repository, can you track data's location from inside the repository? So for example, imagine, I don't know, you have a lot of hard drives, right? And then you put, some files on these, because they're large files. So you put some files on these hard drives.
Oh yeah, what you did with Data
hard
Lab.
drive. And then when you turn them off, like they're all offline, right? So without connecting them, can you track the data location and to know which, for example, hard drive I need to connect in order to retrieve my data?
Of course, because this information is in the .dvc file. There is this hash that gives the location to your cache, and then in your cache there is the location to your remote. So yeah. The config file in the .dvc gives the location of your remote. So if, for instance, you need to mount a certain hard drive to access a certain remote, you would have the path to that mounted drive, and like when the drive is not mounted, the DVC still knows where the remote is, but of course the remote is not accessible.
Right.
And if it is for instance, on Azure, it will have the URL, but the same thing. Like if you don't have internet access, well, it doesn't lose the information, but it just cannot reach it. Okay. So yeah, you could have. If you have a lot of data that's split amongst many remotes, that's totally fine. You would have the config file would have more remotes. You can have as many remotes as you want in there. They just new lines get added each time you add a new remote, and yeah.